Alright, we want to look at a problem using energy conservation, and in this problem we want to send something down a hill. And we'll start with a box sitting up on top of a hill, and our box is initially at rest at the top of the hill. So our box has an initial velocity equal to 0, and let's just say our box has a mass of 10 kilograms. Now our box is going to slide down the hill, and when it reaches the bottom of the hill, it will have some velocity for reaching the bottom of the hill, and we want to figure out what velocity this will have when it reaches the bottom of the hill. Let's assume that our hill is 3 meters high, and we want to know the velocity down here once it reaches the bottom of the hill. So to do this first part, we're going to look at energy conservation. In our energy conservation, we know that the energy here, the energy initial here, has to be the same as the energy final down here. So our energy initial, in this case, the initial energy, well, energy in general, is our kinetic plus potential from gravity plus potential from the spring. And E initial is equal to 0 kinetic, because kinetic energy we said was 1/2 mv squared, and since our v is 0, we have no kinetic energy. Gravitational energy, we said, UG, this was mgh, and in this case m is 10, our g is 9.8, and our height is 3 meters. And then our system doesn't have any elastic energy or spring energy. So that makes our initial energy equal to 10 times 98 times 3. That's almost 300. It's like 294. We'll just say it's close to 294. And when we look at our energy final, what do we see energy final being? Well, energy final, it has some 1/2 m, which we said is 10, times v final squared, because we don't know v final. When our object is at the bottom, h is 0, so we have no potential and no spring. So what do we see? We see that E final is equal to 5v final squared. So for our energy to be conserved, E initial has to equal E final, and so 294 has to equal 5v final squared. So we divide both sides by 5, and we see that v final squared is equal to roughly 58, almost 59. We'll round it to 59, so v final is the square root of 59, whatever number that is. So we can see that using energy conservation, that we had some initial energy that was all in the potential at the top of the hill. When the box goes to the bottom of the hill, we see that our energy converted from this potential over to kinetic, and then our object had this kinetic energy at the bottom of the hill because it was moving now with some speed, which was about the square root of 59.